These are notes about the special parallelograms. There are 3 special parallelograms. Again, I'm just going to go over this. You have all of the notes written down already since I was not here last class. So I'm just going to hit the highlights with you so you understand what I mean by all of these things. Okay, for a rhombus, that's the first special parallelogram. First of all of the rules from your notes about parallelograms apply, meaning there are 2 sets of parallel lines and all of the properties from that set of notes. But in addition, a rhombus is going to have 4 congruent sides. So no matter what one side length is, that means all of the side lengths are the same length. Yes? Check. It's going to have perpendicular diagonals, which means that the diagonals will meet at a what kind of degree angle? 90-degree angle. Additionally, the diagonals bisect a pair of opposite angles. That means that they cut the angle that they're touching in the corners here perfectly in half. So if this side is 30, what's this side? 30. They're congruent. It bisects it, makes it perfectly the same. So if you look at the questions here, if BC is 9, if AB is 9, what's BC? 9. All of the sides are congruent, so they're all the same measurement. For AC, I'm looking for the entire diagonal. If this piece of the diagonal is 7, what's this piece? 7. That's left over from a parallelogram rule. Parallelograms said that the diagonals bisect each other. So what one side of a diagonal is, the other side of the diagonal is. And then last but not least, ADC, this angle right here, the rule from parallelograms again still applies, which means these 2 angles, this guy and this guy, have to add to 180 because they're supplementary. So to solve for number 3, what I did is I noticed that if this angle is 44, it means immediately that this angle is what? 44, because they bisect each other. So this whole thing is 88, and that means that this angle has to be supplementary to it. So I did all of those things adding up to 180 and solved for angle D. That's the rhombus. So the rhombus uses all of the properties of the parallelogram and then some more. Then we go to a rectangle, a shape you're probably used to seeing. The rectangle, all parallelograms, and I don't know why it says and rhombus, it shouldn't say that, all parallelogram rules apply. So this is a parallelogram. It's just specifically a parallelogram where they have 4 congruent angles. If these angles are congruent, I used this particular shape in the angles. What does that mean each of these angles are worth, measurement-wise? 90 degrees. So we have 4 90-degree angles. We also know that the diagonals themselves are congruent. That's the rules with rectangles. So one giant one diagonal is exactly the same as the other diagonal, and that's new, that's different from the other shapes. So in the problem we had here, we used that knowledge to answer the questions. Again, I'm just hitting the highlights here. You already have the notes written down. That's basically it for rectangles. That the 90-degree angles for all 4 and the entire diagonal is the same. Those are the new properties you add for rectangles. On the back, we had our last shape, which was the square. For the square, it's all of them put together. So it is the rectangle, the rhombus, and the parallelogram rules. All of them apply for the square. With a square, the things that are added, again, because it's all of the rules for parallelogram, rhombus, and rectangles, most specifically, and probably what you're used to seeing, is that this is a parallelogram where you have 4 congruent sides and 4 congruent angles. So you have to see those shapes on here to know that it's a rectangle, but literally every other rule applies. So if you look in the problem here, I asked you to find PK. Well, PK is this part of the diagonal. And based on our parallelogram rules, which still apply here, we know that they bisect each other. So this part is a half, so this part is a half. I then asked you for the measurement of angle PKN. Well, if we follow P, then K, then N, PKN is one of the diagonal angles. All of these are going to be what degree? 90, period. That's always true. Then if we look for MNK, so if we find MNK, MNK is like part of this corner piece. But there is a rule with rhombuses, which applies to squares, that these bisect this angle so it's cut perfectly in half. What's half of 90 degrees? Ooh, actual question I want you to answer. What's half of 90 degrees? 45. So this is 45 and this is 45. So we know that MNK is half of 90 because it bisects 90, so it's 45. The main gist of these special parallelograms is that they're all related to each other in this Venn diagram family. Every single picture, every single one on here is a parallelogram. But when we get more specific, a parallelogram where there are congruent sides is called a rhombus, or rhombi, which is the plural version. A parallelogram where all of the angles are congruent is called a rectangle. A parallelogram where the angles and the sides are congruent is a square. So the square is the baby of the rhombus and the rectangle, but they're all a part of the parallelogram family. So the markings are what are important. You have to make sure that the markings that you see actually show you what you want. So if you don't know that it's actually a square, like in number 11A, there's nothing telling me that those sides or angles are congruent, which means I can only say that this is a parallelogram. Don't let your eyes fool you. On the second one, since the tick marks are on all of the sides, that's information to tell me that it's a rhombus. For number 11C, since I have congruent angles, I'm then allowed to say it's a rectangle. And on the last one, because you don't have any other information about the angles or that all of the sides are the same. In fact, it's not even a parallelogram because there's no parallel lines. You'd have to go back and call this just a quadrilateral. And actually, the next lesson we're going to do, which is going to happen today, since we're doing 2 lessons in one day, I'm going to teach you what that shape is actually called, and we'll learn about the properties of that shape. But your lesson last time was to talk about the rhombus, square, and rectangles. So what I'm going to do for you is I'm going to give you about 10 minutes to rework on the homework assignment from last time. This time, it will actually become homework if you don't finish it, but I think in 10 minutes we'll be able to work through these problems. So you're going to look at the characteristics of each shape. It goes rhombus, rectangle, square on the worksheet, and you're going to find the answers to all those questions. There is an answer bank at the bottom so you can know if you're at least on the right track. Okay, you can work together on this. I don't mind that. That way we can discuss about rectangles, rhombuses, and squares. And in about 10-15 minutes, we'll switch to today's lesson to get started. I'm also obviously here for you to ask questions.